Hello everyone, this is Rathan Babu, working as an assistant professor in the Department of Aeronautical Engineering. I am here to discuss on the topic need of computational fluid dynamics and its applications in various branches of engineering. So basically, what is CFD? So what is computational fluid dynamics? So computational fluid dynamics is a tool which is used to simulate fluid flow and analyze the fluid flow behavior using numerical techniques. So let's say if you want to visualize, so let's say this is a room, okay, so there is a fan here, okay, so it is rotating with certain angular velocity. So how the flow is moving around the room, if you want to visualize, so CFD can help us actually. Okay, so this is one of the realistic example. And so here the fluid, so basically the fluid can be air and water. So there are different types of fluid, so Newtonian fluid, non-Newtonian fluid. So air and water comes under Newtonian fluid, where so stress for applied stress, strain is proportional. So in the case of non-Newtonian fluid, so your applied stress and strain are not proportional. So example, blood, okay, and you can take honey, okay. So these comes under non-Newtonian fluid. So basically in this course we are discussing about Newtonian fluid. So either it can be air or it will be a water, okay. So if we are talking the governing equations, or if we are seeing the flow analysis using air, then we are seeing computational aerodynamics, okay. So the fluid can be either air or water. So basically the general word is like computational fluid dynamics. Fine. So yeah, so basically here the CFD is a tool which is combined with the help of fluid mechanics and with appropriate mathematical techniques, okay. So basically fluid mechanics so deals with the forces involved and the motion of the fluid particles. So let's say air is moving from station 1, so this is, let's say, station 1 and this is station 2. So air will go from higher pressure, okay. So if pressure is higher pressure to lower pressure, okay, air will move from higher pressure to lower pressure, okay. So let's, for if you see the air, so you have fluid particles. So fluid particle, we can take it as a cubical or any other shape. Let us take it's a cubic shape. So it will have u direction velocity and v velocity and w velocity, in the sense x, y and z coordinates. So if you see kinematics and dynamics, so it will have the position and it will have velocity. So basically when a fluid particle, it can be air or it can be water particle. So if it is moving from one point to other point, so you need to know what is its position and what is its velocity. That is very important. And what are the forces acting on it for the motion, okay. So this is like flow from station 1 to station 2. So when you have a object here, let's say, so when you have an object here which is stationary, when this fluid particle is moving and hitting this object, so there will be a force, okay, action and reaction force. So basically here the branch of fluid dynamics and mechanics, so it will deal with how this fluid is behaving when a stationary or a moving object is placed in the medium, okay. So in order to visualize these things with appropriate mathematical techniques, so CFD is a very useful tool to visualize these things, okay. So basically computational fluid dynamics is an emerging tool, so which is used to simulate any fluid flow problem. So it can be flow through a pipe, okay, like you have chimneys, you have so many applications, okay. So let's see what are the different approaches used to solve a fluid flow problem, okay. So in general, initially people used to use analytical fluid dynamics, so where people used to solve equations. Let's say you have a continuity equation, du by dx plus dv by dy is equal to 0. So this equation is like incompressible continuity equation. So here you can see people used to solve in 80s or 18th century or 17th century, these kind of in those eras. So people used to solve equations using by hand calculations. So those are like analytical fluid dynamics. So and they used to solve these equations to see what is the effect of fluid over any body. So then later people have developed this experimental fluid dynamics. This has helped to set up a virtual setup, okay, to see how the flow is behaving over a particular body when a model is placed in an experimental setup. Okay, so after conducting these experiments, so people used to study what is the behavior of the fluid over a particular domain or a body, and what is its effect. So how can we optimize the shape of the body, or how to decrease the drag, how to increase the lift of an aircraft. So these kind of things are estimated. So that is, so experimental, so analytical fluid dynamics, so it has its own drawbacks. Even experimental fluid dynamics has its own drawbacks. So basically these two are time consuming. So if you take any complex problem, so let's say flow over a rocket. Okay, so let's say this is a rocket of different stages. Okay, so basically if you want to see the flow over this rocket, so you need to see, you need to solve these governing equations here. So when you want to solve these governing equations over this model, it will using analytical method. So it is a time consuming process, so it will take years and decades. So people had sorted out for experimental techniques. So for the experimental techniques, even it has become costly, and it has become costlier, and it was like expensive. So and it is also a time taking process. So these two has its own drawbacks: analytical fluid dynamics and experimental fluid dynamics. So in 1970s, so basically the computational fluid dynamics has come into existence. Okay, so computational fluid dynamics has given a path to solve a fluid flow, complex fluid flow problems using numerical techniques. So basically we will set up a model using some techniques, using mathematical technique, and we will simulate flow over this model using mathematical equations. Okay, so this is what in broad CFD is. Okay, so here are some of the major applications of CFD. So here you can see the flow over an aircraft. So here you can see that in this model, so here aircraft is assumed to be stationary. Here flow is moving with certain velocity. So here this contour shows the velocity of the fluid over this aircraft. So since it is air, so here you can see it is coming with some velocity. Let's say it is 220 meter per second. Okay, so when it is coming from a free stream velocity, it is encountering flow on a body. You can see that on the wing, in the starting portion, it is expanding. The flow is expanding and it is increasing. So here you can see the blue color region. So there is a secondary flow which is forming. So this is a delta wing configuration. So it's a fighter aircraft. So you can see how the flow is behaving when it is moving on a fighter aircraft. So what are these here you can see that there is a secondary flow formed. Okay, so there is a low energized pockets which are formed here on the both sides of the wing. So after investigating these things, so people will study how to improve this design configuration such that we can mitigate this. Okay, so this is how this CFD tool help us to visualize for a given example here for aircraft. Okay, and we need to improve the performance of this aircraft. Let's say, so what happens if aircraft is moving with certain velocity in the air, so the drag, so the resistive force offered by the fluid medium will increase actually. So in order to minimize this drag, you need to design your aircraft configuration with an optimal way. Okay, so you need to see what should be your wing design configuration, what should be your nose design. Okay, so these things has to be seen separately. So basically CFD will help us to see how, if we are improving the design, so how we are able to mitigate this drag or this secondary flow pockets for this particular example. Okay, yeah, so there is one more example. Here you can see flow over a car, and here you can see that this is actually called turbulent flow. So where you have random and mixing of fluid flows in a given fluid region. So you have two kinds of flows. One is laminar, so which in which the flow is regular and smooth, and turbulent. So basically turbulent is nothing but, so you have the fluid, this is turbulent, and this is laminar. Okay, so laminar flow is nothing but where fluid flow is very smooth and regular. So you can see turbulent, it is chaotic, and mixing will happen. So here you can see that the flow here is chaotic and it's turbulent. So basically what is happening, because of this turbulence which is occurred on this entire domain, which is on the car, so this will actually reduce the speed of the car or the performance. So basically you can see the various designs of car, like if you see Audi or BMW, or let's say Sandro Zinc or Wagoner, so you can see there is a difference. So if you take Audi, it's a streamlined, so you can see it's like streamlined car. So when you take an Wagoner or this thing, so it's like a blunt. Okay, so why? Because people have seen, so what should be the optimal design configuration such that they can mitigate this turbulence. So that's why you can see that Audi is very expensive, and this Wagoner compared to Wagoner. So CFD plays a major role in all various branches. So previously we have seen in the aircraft industry. Now you can see in the automobile industry, which is car, and here you can see the civil industry, where you can see the flow over buildings. So here basically the flow is simulated to see. So here air is moving from this region, and it is passing over these buildings. So when this air is moving with certain velocity, so you can see that in buildings we have some colonies. So how the ventilation is happening in the cities. So if you have these buildings, so how the flow ventilation is happening, and what is the effect of this wind on this building, that is also estimated. And this is called this urban visualization. Okay, yeah, so the major application right now people are seeing for the COVID. So even in order to estimate, so what is the flow visualization of a cough from a human body, so this can also be estimated using CFD tool. So here you can see that it has been ejected with a velocity of maximum 0.9 meter per second here. So here you can see how fluid particles are spreading after uh, after the human ejection. Okay, so this will, CFD will help us to visualize any fluid flow particles, whether it can be air, water, or you can see all type of applications, medical applications, engineering applications, chemical applications. So there is no like n number of applications for CFD. So in today's world, CFD has become a major tool to uh, to get answers for a complex domains. Okay, so thank you.
Like, share, and subscribe. Hit the bell icon for more updates.